गुड मॉर्निंग फ्रेंड्स। आज का टॉपिक है SN2 रिएक्शन। SN2 रिएक्शन इन विच S स्टैंड फॉर सब्स्टिट्यूशन, N फॉर न्यूक्लियोफिलिक and 2 for bimolecular reaction. Alkyl hydrolysis of methyl bromide gives alkyl methyl alcohol is an example of SN2 reaction. This is CH3Br methyl alcohol plus aqueous KOH. It gives methyl alcohol plus KBr. This reaction in ionic form, that is methyl bromide reacts with OH minus gives methyl alcohol plus Br minus. In kinetics, kinetic study of SN2 reaction state that rate of reaction depends on concentration of both substrate as well as reagent, means nucleophile. OH minus is nucleophile and CH3Br is substrate. That is, R is directly proportional to the CH3Br raised to power 1 and OH minus raised to power 1. We taking a constant which is specific rate constant, that is K. R is equal to K. CH3Br, concentration of CH3Br raised to 1, OH minus raised to 1, where K is, that is specific rate constant, and order of reaction is second order reaction. Second point, mechanism of reaction. Methyl bromide CH3Br is react with OH minus. OH minus attack on the back side because in front side there is Br, that is halogen. Halogens are the bulkier in nature, therefore OH minus attack on the back side and forming a transition state, that is CS3, that is forming transition states. This is the slow step we call as RDS, that is rate determined step, and then form methyl alcohol plus Br minus. SN2 reaction is a single step reaction. First step is a slow step called as rate determined step. We know that it is rate determined step. Backside attack of nucleophile. Nucleophile OH minus approaches CH3Br from the backside. Nucleophile OH minus approaches from backside of CBr bond. This is because leaving nucleophile Br repels approaching OH minus. That is, halogens are bulkier in nature, therefore it repels in front side, therefore OH minus attack on the back sides, called as backside attack. Then second is transition state. When nucleophile attack CH3Br, that is from CH3Br from backside, this backside, then making of COH bond and breaking of CBr bond, making of COH bond and breaking of CBr bond take place simultaneously. At the state, potential energy of system increases and it is become least stable. We know that in transition state the potential energy of system is very high and the system is least stable or unstable. This state is called as transition state. In transition state, both the nucleophile and the leaving group acquire partial negative charge and carbon acquire partial positive charge. Here OH minus and Br has partial negative charge while carbon has partial positive charge. Then formation of product. After the attack of OH minus on methyl bromide, breaking of CBr bond and take place completely and making of COH bond take place fully, result in the formation of product, that is methyl alcohol, which is the final product. Then second point, that is Walden inversion. When nucleophile OH minus attack on CH3Br on backside, then the position of the hydrogen bonds atom in CH3Br moves in opposite direction to that of the CH3Br in methyl alcohol. This opposite arrangement of hydrogen atom is in the product referred as 100% inversion. That means in this reaction the 3 hydrogens are at the left side and in the product side the 3 hydrogens are in the right side. That is, the 100% inversion is take place. This inversion is called as Walden inversion. Then the energy profile diagram of SN2 reaction. In the energy profile diagram, rate of reaction is as follows: when methyl bromide, that is CH3Br, react with OH minus, then the energy of system increases to forming a transition state. In transition state, the OH bond and Br bond are in simultaneous, that is OH bond is making and CBr bond is breaking. The energy of system is high at the transition state. This distance from the reactant to the transition state called as EA, that is energy of activation. And then the energy is decreases and forming the product, that is 100% inversion of methyl alcohol. In this way, the energy profile diagram of SN2 reaction is explained. In this way, the SN2 reaction is completed. Thank you for the watching the video and please subscribe the channel.